Tomorrow will be better. Can two identical substances at the same temperature have different thermal energies? Before everything, let me draw your attention to these keywords. We have identical substances and then we have thermal energy. Now, the identicality here refers to the fact that they may have the same specific heat capacities, which means they are made out of the same materials, okay? Now, is it possible that if they both have the same temperatures, they end up having different thermal energies? That's the question. Follow me, dear friends. Solution. Before everything else, let's remind ourselves the factors which affect the thermal energy of every substance. We have that Q, or the thermal energy, is given by MC, change in temperature. Now, this factor is already the same because we are told that they have the same temperatures. Now, because they are identical substances, it means they are made out of the same material and thus have the same specific heat capacities. Therefore, the only other factor here which is not specified is the mass. No wonder, look at this. How does mass and heat quantity here vary? There is a direct proportionality between the two quantities, which means for two substances which have the same specific capacities and the same temperatures but have different masses, it's obvious that they will have different thermal energies. Let's analyze it more specifically. Now, for substance 1, Q1 is going to be M1C delta theta, and for substance 2, Q2 will be M2 still MC delta theta. For some reasons, if M1 happens to be greater than M2, then Q1 will also be greater than Q2. And in simple English, what this means is that a small cup of boiling water is not as hot or doesn't feel as hot as a whole pot of boiling water, because the whole pot of boiling water has a greater mass than just a little cup of boiling water. Tomorrow will be better.